All right, today is Monday, January 4th, 1/4, not 2020, 21. I made that mistake in my first period class. I try to not make the mistake anymore. Bar was set real low, 2020, 2021, you better be better. We will make it better. Our objective today, Andrea, is to
sketch a slope field when given a first derivative.
there it is. And slope fields look super, super cool. Once you can also have like computer programs automatically generate them. And I think they would make a great cover page for a binder. Anyway, let's talk about slopes because it's a slope field. So slope at a point. If I gave you some sort of differential equation, I said, hey, I know what y prime is. Y prime, or dy dx, if I want to be more formal, or the derivative of y with respect to x, if I'm being extremely formal, is equal to x times the quantity of y minus 1. So I've given you y prime. And then this is a separate problem. Don't worry about him or her. I don't know. So with this first problem, what happens if I look at the point 1, 1? And the way that I write this is it's dy dx, evaluation bar 1, 1. I usually put that in the bottom right so you don't confuse it for a power or multiplying or anything like that. So I'm substituting that in. What happens? Well, you literally just plug in the x coordinate is 1, the y coordinate is 1 into this equation, and you get the following. You get 1 times the quantity of 1 minus 1, and that's equal to 0, which means the slope at this point, 1, 1, is 0. It's that simple. And I can choose any point. I'm just going to choose another random one, 2, 3. If I choose 2, 3, Fiona, and I plug that in, I get what slope?
Or 4?
4, yeah, exactly, because 2 times the quantity of 3 minus 1, or 2 times 2, which is 4. So you can have slopes at individual points, and eventually that will make a slope field. But let's practice a little bit more. What if I told you that y prime over here is 2x? There's no y. What do I do, Mr. Sindel? Well, you can say plus 0y if you want, or you can just have the easier rule of if there isn't a y, don't worry about it, ignore it. So all of these have x, y, just that second one, that 0, just cross it out. It doesn't matter. Ignore it. So nice and easy, Teflon. What is the slope at 1, 1?
I don't know how to do this.
Okay, well, the equation is 2x. So 2, then what is the x coordinate?
Oh, 1.
1, which is
2.
2. There it is. So the slope at 1, 1 is 2. All we're doing is we're plugging in the x and y coordinates into whatever it tells us, the equation up here. Yeah, and let's give you another one, just to make sure you know what you're doing. So if I have this point -1, 0, and the equation up here is just 2x, what is the slope at this point, -1, 0? Teflon?
Oh, sorry, I didn't know you were talking to me.
Yes, sir.
Is it the same way?
Kind of the same thing, yeah. So what do you do?
Would it be -1?
So -1 is the x coordinate, and then you plug that in and you get
Oh, -2.
-2. Yeah, nice. Cool. And then we just have to practice graphing a few things and we're ready to go. By the way, a differential equation is what we're working with here. That's the formal name. So what is a differential equation? Well, dy dx, that is a differential equation. Let me just give you a bunch of different forms. You could have, I don't know, dw with respect to dt, like with respect to time instead of x, or I could have, I don't know, dy dt, I don't know, dz dx. These are all known by the name of differential equations. They sound scary, but they really just mean they're giving you the derivative. They're giving you y prime. They're giving you w prime. They already took the derivative for you. Plug in some stuff. We'll be working with differential equations in future units as well. So just a heads up on vocab. All right, so these are the slopes that you need to be able to graph for the AP test. And it's sometimes you have to graph like a slope of 4 and 2. Like there's other ones too, but if you know these, you should get like a ton of them correct. So again, whenever I'm saying dy dx, that really means slope. So slope is equal to 0. That's another way to interpret this. Slope is equal to 0. That's a flat line. You have no heartbeat. It is shwink, that nice little horizontal line. All right, I take a bow. Whew, that was hard. Slope of 0. All right, you guys, you girls, I should say now, because Chris isn't here. Graph a slope of 1. And hopefully you went right 1, up 1. So there's your slope of 1. Graph a slope of -1. Hopefully you're going to right 1, down 1. Ooh, graph a slope of 2. And again, you should be able to sketch these. And I went right 1, up 2, right 1, up 2, just to make sure I got the slope of 2. And -2, right 1, down 2, right 1, down 2. So when you're sketching points around or sketching slopes at points, you need to make sure that your slopes of 1s don't look like the slopes of 2s. They do need to look different. I can't tell you how many times I've created a test. I'm like, this is supposed to be a slope of 4, but it looks like a slope of 1. I don't know if the student knows what they're doing or if they just don't know how to graph slopes. So make sure you really have your slopes down. All right, so let's do our first slope field. Here we go. Here's a differential equation. There it is. Here's your differential equation. It is 2x. Ooh, really hard. Here we go. So slope field. At every single point, will need to graph a slope. So I have I have 25 points here. It's 5 by 5, right? So I'm going to have 25 different slopes, which is a lot. But remember, all you're doing is you're taking the x coordinate. Since there's no y coordinates, it's gone. You're taking the x coordinate, multiply that by 2. That is the slope. Let's just start in the top left. Why not? The top left, the x coordinate is -1. So the slope, therefore, Fiona, is?
-2.
-2. So make a slope of -2. I'm just going to move from, oh, actually, it would be make more sense to go straight down from here. Andrea, what is the slope at this point? -1, 0.5.
Just be -2.
-2 again. And what shortcut could you use to talk about the rest of these 3 points?
It's all -2 because the x coordinate right there
Exactly.
is -1.
If it only depends on the x coordinate, just by moving y coordinates, it's not going to change anything. Exactly. So I'm just going to copy paste that same slope of -2. Perfect. All right, Teflon, you're up. This point at -0.5, 1. So I'm looking at this point right here. What is the slope at that point?
-1.
-1, yep. And still on you, Teflon. Teflon, what is the slope at -0.5, +0.5, this next point?
Would just be 1.
+1 now?
Wait, no, it would still be negative.
-1, yeah. And in fact, it's going to be the same rule that Andrea said. I don't know why my lines are so much shorter, where you're just going to keep copying that slope over and over and over again because it doesn't depend on the y coordinate. And then Fiona, what is the slope going to be at the next 5 set of points?
0.
0. So we go 0, 0, 0, 0, 0. Andrea, the next 5 set of points are going to have a slope of
1.
1. Yep. So 1, 1, 1, 1, 1. And then Teflon, the most right side points, these are all going to have a slope of
2.
2. Yep. So 2, 2, 2, 2, and 2. Cool. I mean, it might not look like much, but that is your first slope field. Why is this a solution? This is technically a solution to your differential equation because we don't know what our plus c is. So let's really think logically here. Do we have a backside? No, we're basically done after this. So when I have a y prime, essentially this is telling us, hey, y prime is equal to 2x. What is the original equation? Well, we don't know, because when you take the antiderivative or the integral of 2x, you say, okay, well, that goes up a power. That's going to be x squared plus c. The whole problem here is you don't know the plus c. But if you have some sort of initial condition, if I said, I actually happen to know C is negative 0.5. Well, if I know that there's a point here at 0.5, I follow this path that's drawn out for me and say, oh, well then this is the graph that I'm actually talking about. This slope field accounts for every possible C. So it could have, like, let me draw one of the solutions. One of the solutions might have been something that looked like that, because I chose my C to be negative 0.5, and it just follows the lines of my slope field. Or maybe, and I can use technology and copy and paste this, what if I change my C something else? Well, it would just shift the function up and down, because that's literally what's happening here. It's a quadratic equation, just x squared, your parent function, and I'm just shifting that up and down by C. And that's what all of these lines are telling you. In fact, if you want, you can go to GeoGebra, and you can actually set up a slope field. I haven't done this in a year, so I hope I know what I'm doing. And GeoGebra makes some really, really cool slope fields. And it's a way to check your work too. I guess I could do online GeoGebra too, but I'm going to do the application because I want my computer to die. Can't handle Zoom and all this stuff. Slope field. Yeah, slope field, and then you just type in a function. So in here, I'm going to do, I don't know, 2x. No, it wants me to get rid of those things here. Boom, there's your slope field. That's what we just created. And if I drag this around, the slope field obviously changes with it, but I can change that slope field. Like, let's try a new slope field. What if I do something more difficult? Slope field of, I don't know, let's do 2x squared minus 3y. And you get like some cool slope field. So I don't know. I think that slope fields are pretty freaking beautiful. And you guys now know how to create them by hand. Obviously, you can just type it in the computer and it does it for you, but you know where they come from. You're just taking the point, every single point, you want to figure out what the slope is. Cool, that's all I got for you today. We still have 10 minutes now to do homework, or sorry, 20 minutes to do homework. Let's do a fist of 5 really quickly on your objective. How well can you sketch a slope field when I give you that first derivative? Fist of 5. 4, 4, 4, 5. And I can't see Teflon. The background is making it really hard. 4. All right, cool, thank you. And as you're pulling out your homework, just as a heads up, there are 3 lessons for this unit and we are done.